Hello everyone. Welcome to my talk at the stage of Java 2022. Today I'm going to be talking about the benefits of MQTT for IoT apps and beyond that. My name is Mary Grygleski. I'm a senior developer advocate at HiveMQ. So a little bit about myself. I'm currently a senior developer advocate at HiveMQ. Previously, I was at IBM for 3.5 years as a Java developer advocate. I'm based out of Chicago, and I'm also a Java champion and president and executive board member of the Chicago Java Users Group. And I'm also a co-organizer for a couple of IBM-sponsored meetups in the Chicago area. I have extensive experience in product and application design, development, integration, and deployment experience. And I specialize in reactive Java, open source, and cloud-enabled distributed systems. So let's begin. Today, this is the agenda. I'm going to first start with talking about the IoT stack, what it is about IoT that is kind of so exciting and everything. Let's get kind of a clear understanding of the whole picture. And then I'll get into MQTT, about a brief history of MQTT, and then the OASIS open standard that it is. It's really very much a community-driven protocol, a project by the community. And I'll then get into the MQTT 3.1.1 features, after which I'll discuss a bit too about the 5.0 features, which are newer. And then I'll get into some use cases for MQTT, and also discuss a bit about the alternative protocols for IoT. And then finally, the benefits too and strengths of MQTT for IoT. Now, if we have time, then I'm going to get a bit into some demos too, to kind of give you a sense of how easy it can be to be leveraging MQTT, especially using the HiveMQ broker. So first, let's start, from the 30,000 feet. What is it that, the IoT stack is about? So let's first start, when I first started working with IoT, like immediately, I'm kind of thinking of Raspberry Pi, Arduino, all these small devices. And I'm trying to do device-to-device communication. Very true. We can do that too. But IoT itself is stretches beyond just that small pieces of microcontrollers, as some of you may already be aware of. So first of all, as we know, right, there's the OSI network layer, the 7 layers. So when we come to talk about IoT, the stack, it really encompasses more than just that networking layer. So as you can see, first of all, let's take a look at the physical devices. So these are smart devices, sensors and actuators, embedded devices, things of that nature. So those will be the kind of devices we want to be able to kind of establish communications between. Now, it can also be other bigger machines as well too, but essentially we need, at least 2 devices to be able to exchange data. And then now let's get into a bit of the mechanism, right? Kind of like the protocols, the communication protocols that will enable devices to be able to communicate with one another. So here it is too. I actually have deliberately, because of the complexity of this subject matter, I basically compressed the whole communication protocols as I abstract out to represent the OSI networking, the 7 layers. So over here too, as you can see, this is where MQTT kind of fits in. It's really on the communication protocol side. But as such too, MQTT is on the application layer of the OSI layer. So over here too, I have grouped together just a small handful of samples of some of the protocols that are used here: MQTT, CoAP, AMQP, DDS, and XMPP. And then of course too, there's also the TCP layer, the IP layer, all of the different layers, the application, session, and then presentation, and then if you kind of keep going down, the IP layer, the networking, the physical layers, down to, Ethernet and the physical link and everything. So if you look into it too, then there's also IPv4 that we need to rely on, or the IPv6 or 6 low PAN, which is like the low powered IPv6 protocol, IP protocol, and then Bluetooth, GSM, Modbus, and BACnet. These are just a tiny little handful of all of the protocols that kind of can be enabled for this layer to kind of enable all of the devices to communicate between one another. Now the thing is too is that as we kind of go up the layer of the IoT stack, we look into also, so to speak, the core platform. So the core platform is what it takes is that it takes all of the stuff that's underneath and then it builds on top of that. So say for example, right, IoT messaging middleware, and that's where HiveMQ is kind of excel in, is this providing services, right, as a middleware kind of service, right? The broker, the MQTT broker, is kind of built on top and uses the MQTT protocol too. So over here too, as you can see, core platform, we have IoT messaging middleware, there are protocol gateways, data aggregation, data storage, and filter. All of these are kind of helping too in this IoT stack, because after all, we're trying to deal with data that travels, across different devices and different machines. And then if you kind of climb further up into the IoT stack, and as such too, when I kind of first look into IoT, I realized that when I look into some meetup groups and people were coming from the AI, the machine learning side of things, and they are interested in IoT. Now, of course too, because if we kind of look at everything in today's world, we can no longer kind of isolate ourselves and saying that, well, I'm only doing IoT or I'm doing MQTT. The fact is that all systems, are kind of being leveraged upon to build solutions that will solve problems that we face every day. And that's what we're trying to solve. And IoT, the stack as such, is so complicated and encompasses many things, anything you name that can be an IoT, that form an IoT stack. So if you look into the analytics platform over here, there can be, reports, events, machine learning, all of these stream processing. They could be, using data that's been collected from IoT devices too. So to help you to do that type of work, right? Services like geospatial platforms and recommendation engines and things like that, you name it, it's really can be considered, an IoT within the IoT stack. And then if you travel further up, the cognitive platform too, that basically it deals with like interactions type of systems like gestures, facial recognition, spoken systems, voice recognition, AI. And then now if you go really onto the very top of the stack are essentially the solutions layer. Solutions layer are kind of again, not limited to these three, but I have broadly categorized these three into consumer type of solutions, which include like, your home devices like alarm systems, your wearables for lifestyle thing, mobility, your mobile phones, and trying to communicate and entertainment, all of these things. And then enterprise too, systems such as ERP system, marketing system, sales, business operation kind of systems on the enterprise solutioning side of things. And then there's also industrial too, which kind of involves like manufacturing, automotive industry, connected cars, logistics, and construction. And these are just a small handful of example of what this IoT stack means. Now let's kind of get into the meat, in here, which is like about MQTT. So what is MQTT, right? So I kind of show you that's a communications protocol. So it's really a standard binary publish subscribe messaging protocol designed for fast and reliable data transport between devices, especially under very constrained conditions. So that's the key word here. Very constrained, so as such too, when we deal with devices, right, they are relying on the internet, relying on some networking. But guess what? We always as developers, let's say, that's how I began my technology career, and we kind of treat the network as though it is reliable, but in reality, we know that the network is never reliable. That there's always something, So in this case, right, device to device communication, you carry all of these data. You want to make sure the data doesn't get lost, during, in transit and everything too. So that's what is like meant by kind of constrained environment, because the devices itself probably have very limited memory capacity, different kind of limited like storage space and everything, and the network is unreliable. So it's not an ideal environment for any data to travel across. So this protocol has been designed especially to handle that kind of very constrained type of environments. So, and then it's built on top of TCP/IP, and it's really ideal for the Internet of Things. So now take a really, really quick example here behind me. So that's like an example of an MQTT broker that HiveMQ develops, right? So this broker too is kind of forms the crux, the heart of this whole system, the messaging system in here. So essentially too, the broker too will be the one that's kind of a center place where it collects all of the messages from the publisher. And then from the publisher too, they will distribute to whoever is interested in subscribing to the topics of these messages. So these messages are basically categorized in terms of like by topics, so to speak. So basically in this particular case too, we're trying to have a speed meter that collect the data from a speed meter that basically if data comes, then it publishes the data to the broker. Now, then they will be labeling this message to be of a certain topic. So whoever then is interested, let's say there's somebody with a mobile device and with a backend server, they're interested in the speed, collecting some data, then basically you will need to subscribe to that topic, and the topics are all kind of managed by the broker. So when it comes time, the data comes, then the broker will then distribute the messages to whoever have subscribed to this particular topic. So that's kind of like the kind of like in a nutshell, that's how MQTT works. But of course too, this sounds simple, but it's actually in reality has all these kind of special kind of scenario that this protocol needs to be handled. So let's kind of get kind of into the crux of things here. Okay, but before I get into everything, let me give you a bit of the history, right? So MQTT, if you kind of like talk about it, right, it stands for message queue, telemetry transport. And this particular protocol actually was invented back in 1999 by an IBMer called Andy Clark and also with his partner Arlen Nipper. So Arlen did not work for IBM, was working for another company then. The two of them came together to work on a project and consulting project, and the project is to collect data from some oil pipelines. And because the oil pipelines is kind of certain, some measurement that needs to flow through the pipelines, and basically too, the data is being sent like to satellite communication back in 1999, right? The internet was still in its infancy and everything. So they're relying on satellite, and then realizing that the protocol, or kind of essentially there wasn't any protocol that would help with that kind of a constrained environment in which you need to draw data samples from. So then they both came together and designed this protocol. And because our Andy was working for IBM too, of course, it's got the MQ series, right, for the messaging. Basically, it's the message oriented messaging kind of broker technology. So they use that MQ and then they name it telemetry. Add the two things, telemetry transport is basically to kind of like describe, kind of MQTT, and that's how it was born. But in today's world, to MQTT is no longer, kind of servicing that particular purpose, whereas it has been further extended and kind of morphed into the current state in which it is like protocol for handling IoT kind of way of communication. So, okay, that's long enough. And then in 2010 too, MQTT 3.1 then got opened up as a royalty-free protocol. And then in 2012, and that's when the Eclipse Foundation project Mosquito 1.0 was released. And now, as such, it is an open source broker from Eclipse Foundation. Then soon after, in 2013, that's when HiveMQ 1.3 got released. And then in 2013, that's when the governing consortium called OASIS that basically the MQTT has been kind of entrusted to OASIS to be governed there, and so the technical committee is formed. So I'll show you quickly too who are actually involved with the committee shortly. But let's kind of finish looking into this line of history. And in 2014, MQTT 3.1.1 got officially released, and that's the version that's been still been in heavily used too in today's. And then 2018, that's when MQTT 5 got released. That particular version, which I'll talk a bit more, kind of designed to handle kind of scalability, a lot of the cloud native type of way of doing things. So I will kind of show you quickly about what some of the key features are from that release. And then in 2018 too, soon after the MQTT 5 got released, HiveMQ4 also kind of announced support for MQTT 5. So this is the companies that are involved in the technical committee, and they are the basically obligatory members that are there that they can vote for kind of issues too, and so or vote for any things that they want, right? Some features to be taken out or to be modified or to be deleted, whatever is needed. So as you can see, there are 9 companies. So among all 9, as you can see over here, HiveMQ is a very important partner too. And also, by the way, too, HiveMQ is a startup company, but it's actually not that much of a, kind of a short-linked startup. It started back in like 2012 or 2013, and that's when, the founders here too, they work on implementing the MQTT protocol. Now, the thing is too, is that as you can see over here, we have Christian Getz. He is the CEO of the company. And then also Dominic Obermeyer. These two of our companies, they are the 2 founders. They are still very actively engaged today with the OASIS committee and leading MQTT, the specifications too. Okay, so now let's get a bit into the MQTT, some overview. So MQTT is an IoT messaging protocol. It's got like 3 quality of service levels too. So I'll get a bit more into what the quality QoS level means too. Essentially too, it is very important in any kind of messaging systems that you want to guarantee the delivery of the messages, because as such, right, messages get published and you really don't have anything that kind of like take it and monitor it at the same time. So you have to have some ways after it gets published, that basically it gets delivered to where it's supposed to go. So QoS levels, and then there are also retained messages, and then also stateful and persistent sessions too that comes with MQTT. And then MQTT itself too, it's kind of got minimal overhead and it's a binary protocol essentially. So it's very lightweight. It's really designed well to run in kind of small, kind of constrained type of devices. So now, let me kind of bring you into getting you to get to know about some basic features of MQTT 3.1.1. So first of all, too, MQTT, the very significant kind of feature of it is the publish, subscribe messaging kind of model that it uses, right? So what is pub/sub, right? So let's kind of take a look too. In MQTT too, what happened is that essentially, again, MQTT is the protocol. Basically, IoT, you need kind of messaging platform that's basically leveraging on the MQTT to do its job, to really enable all of the messages to be traveling, right, everywhere, to be delivered and everything. So the centerpiece of the MQTT, this service is basically the broker. So the broker kind of acts also kind of as a server. Think of it like that. So I wanted to kind of point out to pub/sub in some ways is like the broker is like your post office, right? I mean, think of the fact that, let's say you are a marketing company, you need to like mail out a lot of postcards, something, right, about your products. You mail out to thousands of customers. So, well, let's say not even 1,000, let's say 500, something like that. Now, the thing is too, for you to be delivering all of your postcards to your customers, would you have time to go through one by one to kind of drive everywhere to 500 places and deliver all of your messages? No, right? So what you do is that you go through the post office. So think of the broker as sort of like the post office in this case, right? It serves what you need to do. So, but then the thing is that instead of you writing a letter and then writing the address of your destination, what you do is you basically have your messages and you kind of label it with a topic. Right, so basically, too, is that you don't know who is going to get to be the recipient, and it's basically up to those who are interested in your messages to be subscribing to that topic. And then when the message arrives, at the broker will then take care of distributing these messages to whoever have subscribed to that topic. So that's kind of like the idea, okay? So think of it like a post office, even though it isn't quite exactly like a, post office. So now the thing is too is that let's take a look, right? There are essentially like three basic commands too. You need to be able to connect, right? First establish the connection. So basically there's MQTT client that needs to get established, connect to a server, to the broker. So that's a connect command. So in order to, the way the protocol works is that you have a command that do something, then basically the recipient side needs to send back an acknowledgement. In this case, there's a connect command, then there's also from the broker, right? The one that's receiving the messages from kind of like the publishing client, then it will say, okay, good, I receive it. So I send back an acknowledgement. And then likewise too for your client too, you can have a subscriber client too, that who these subscribers are the ones who are interested in the messages. They subscribe to the topic. So when you subscribe, you tell the broker, okay, I want to subscribe to your topic. So the broker will then send back an acknowledgement and saying that, okay, cool, I got your subscription notification essentially. So I'll send you back an acknowledgement. And then, likewise, too, for the publishing side, too, you are publishing a message to the broker. So the broker gets the message. Likewise, it will send back an acknowledgement back to the client side. So you can see, too, it's pretty much a connect and then an acknowledgement, except in one case that I'll be talking to you about shortly. But essentially, this is kind of like the inner workings of how PubSub system works too. Now, take for example over here. I think earlier too, I talked about a broker kind of receiving any kind of producer, right, that produces or publishes these messages to the broker. For example, this temperature sensor will publish like a temperature measurement to the broker. And then it's basically the laptop, in this case, some laptop, people having a laptop, they want to subscribe to this, the data. So you basically subscribe to the topic. It's called temperature or whatever. And then likewise too, another mobile device is also interested in this data. So it will subscribe to it. And then when the sensor gets the data, it will get published to the broker. Then the broker will then distribute the messages with the data to whoever, all of these subscribing clients to. So that's PubSub. But now then let's take a bit closer look into a connect command in a bit more detail, which is like looking at the packet itself. So for the MQTT client, you send your message over to the broker, you send a connect command. And the broker, first of all, take a look at the connect command. The connect command will contain like the client ID and a clean session. And then you see a bunch of like optional kind of information. In this case, a username, password, and then this interesting thing is called last will. And there can be a last will topic. A QoS is the quality of service, and the message for the last will and the retain and also keep alive. Now, after you kind of like send the connect, then basically the broker receives the connect packet. It looks at it and examine that, and basically will then send back an acknowledgement back to the sender, which is the publisher in this case, with a session present, and it says true, and then also a return code of 0, meaning that when things are good, then you send back like that acknowledgement back to your publishing side. So that's a connect and connect act. Now, the thing is, let's take a look too, because I talk about will, right? Last will. So what is last will? So basically, it's kind of like a person, right? Like think of yourself, right? If you have to kind of set up a will, because we're not going to live forever, right? So one of these days, we're going to like pass away. So we need to kind of like leave some kind of message, right, for whoever is going to be living after you to know what to do. So in this case, the broker is the key, right? So the client too will then define this your will. It's a last will and testament, so to speak. So the broker, now only if the client dies, then the broker will then go to these packet, look into this packet again. So there's a connect packet with last will topic, last will QoS, and last will message. So these, right? So the broker, right? Let's say I kind of set up this last will, and then I died. And then essentially the broker said, okay, cool, and the client has entrusted me to take care of things for him or her. So I'll then take a look into the topic, and this is the topic that whoever is going to be subscribing to will receive that. And then this quality of service and also the message, I will take this message and basically do a push, that this is, again, with any kind of pops up, this in this case is a push type of operation, is because it's coming from the broker side. It will push the message over to whoever is subscribing to it, this particular last will message. So then, whoever it's subscribing to it will get this message, knowing that the client has died, like that. So again, it is actually useful. What kind of usages, right? Is to implement any kind of like on-off kind of mechanism in a safe way. And it message when subscribing only, when you subscribe to the topic, then you'll receive this particular message. So in this case, the client would then, whoever other, client subscribers will need to subscribe to the last will topic of like this particular case, Hans will, right? /Hans / will, like that. So it will receive only if that particular client dies. So. Okay, so now then let's take a bit to talking about packet. Let's still take a quick look into the publish subscribe case. So for oops, and I think here, so the publish, you will see that there's a packet ID. Now, as you can see over here, it says a gray kind of a note in here. It's always 0 if you have the quality of service equals 0 in this case, and I'll explain in a second. Then you also have to have the topic name, that's important, and then QoS, in this case it can be 1 and 2 or 0, right? And then if it's 0, again, then this packet ID would be 0. But in this case it's 1, so I have to have some kind of valid packet ID. And then the retain flag, right? Do I want to retain the messages? And then payload, the actual kind of content you're trying to deliver. And the dupe flag, the first time you send it is always false. And if you send it a message again, that the dupe flag will become true. So. And then on the subscriber side, look at, that's interesting too. You can subscribe, right, to the packet, right? So you basically are then getting, you can have like multiple topics that are kind of associated with this subscribe topic too, or packet too. So over here too, you see that it contains like packet ID and then also the QoS level for each topic too. So you can have multiple topics in like one subscribe packet too. Okay, so now then let's take a quick look too into retained message, like I talked about earlier. So retained message, essentially, it's basically called the last known good value. So essentially too, let's say a client, right? It's kind of delivered the message, and so basically that last known good value message will be retained. Who keeps it is, of course, is the broker. So basically, the client would decide, if a message is to be retained or not. So if you recall that packet too, there's a flag, in the packet is called retain flag, and that's how the client can indicate whether this message is to be retained or not. So basically, the usage of this particular feature is that you basically want. Let's say your client is taking care of some messages, and so it's all done. So instead of throwing away the message, you can tell the broker keep it. So then if future clients that subscribe to this topic, the last known good value is there. So basically the broker can immediately send this last known good retained messages to future clients quickly too. So this kind of like the purpose of such is basically to speed up the delivery of messages without having had to do any kind of like initialization and then get the value again. So you may say that, well, the thing is, it doesn't take too long to deliver. It is very true. Each delivery of every messages goes through so fast, right? It's basically, we have brokers that can go through delivering messages, like over like in the billions kind of level within an hour or something like that. So plenty of messages kind of go flowing through. But the thing is too is that because the volume is so big, you still want to like limit the time that it takes to deliver any messages. So then you can make this broker, the delivery mechanism, as fast as possible. So any kind of a time saving is always a plus in any kind of messaging systems. So okay, so now let me kind of quickly go over the quality of services. Now there are essentially 3 levels. So 0, 1, and 2. So quality of service is a mechanism essentially that will help with guaranteeing the delivery of messages, from the sender to the receiver side. Zero basically means at most once delivery. And then if it's QoS 1, it means at least once delivery. It can have duplicate too. And then QoS 2 is basically exactly once delivery. So let's take a look at each one of them. So QoS 0. So as such, right, if you take a look at the packet ID is 0. Why? Because the thing is, we do not care, this is a best effort kind of like delivery situation. Basically, the publisher, client was basically saying that, well, I just want to send the message and I really don't care about whether I receive back an acknowledgement. So essentially, that's what it is. So in that case, then there's no need to receive an ACK, then there's no need to actually have any packet ID to kind of like for the message exchange, because it's essentially like a fire and forget type of scenario. And the plus about this is that it is very, very fast, because you really don't kind of wait around to, for the return packet as well. So over here, the rest of the packet kind of we already looked at is kind of remain the same. So it's only like one direction from the client to the broker. Now, let's take a look at QoS 1. So quality of service 1 essentially will have like two trips, right? So one is the publish. So if you publish it, as you can see, QoS is 1. You see the packet ID. So once the broker receives it, then basically the packet ID will get returned in a pub ACK packet, back to the receiver, back to the sender side, which is the MQTT client side. And as you can see, the packet ID will indicate which packet I have received, from the broker. So then it tells the client that, okay, I have received it. So in that case, then client can basically go to rest, right? Now, the interesting thing is that if, it times out and then my client never heard back from the broker yet. So in that case, then the client will then initiate another packet to be sent over there with the same packet ID, and also basically too will be the retain flag will be turned on, will be like, it's actually the duplicate flag, dupe flag will be turned to true, because in that case, then basically you're telling it that I'm resending. That means then there's also a likelihood that the first packet can also be sent over too, and then this packet also get over. That means I'm sending two. But the QoS level is okay. We're allowing duplicate in this case. So that's QoS 1. Now, QoS 2 is basically a more guaranteed and the highest level of delivery guarantee kind of mechanism. So as you can see, there are like two pairs of kind of like a message exchange. So first of all, you want to have the publish packet send the messages over, and it sends it over. And basically, if the broker gets it right away within timeout, then basically sends back a pub rec. So it's basically indicating I've received it, and with just the packet ID. Now, in this case, the MQTT client would then look at the packet and said, okay, cool, I sent you the QoS 2 packet, this particular one, I received, you got it, that's great. So in this case, what I'll do is that I will issue another packet over back to the broker. Now, this part is important because this is how it is being used to guarantee only like exactly once delivery. So it's kind of a very very sure type of scenario. You guarantee only once. So that's where it is. So I sent back another pub rel to the broker. And in this case, the broker gets this pub rel and said, okay, very cool. Now I can complete it. And then it will send back another pubs comp back to the MQTT client to indicate, this has completed. So then this kind of helps to guarantee that there's only exactly once delivery in this case. Okay, so then how about then MQTT4, right? So let's look at the connect message packet detail for MQTT 3.1.1. Now there's a field called version. The version number for MQTT 3.1.1 is version 4. And then when MQTT 5 comes out, then basically this version has been bumped up to 5. And then that's also then, kind of affect the, affect the MQTT versioning to kind of get bumped up from 3.1.1 to 5 because it want to sync up with the version number that's inside this connect packet. So that's the only reason. It's a bit of a trivial kind of information for you. So Okay, now then let's get a bit into MQTT 5. So let's take a look, right? So MQTT 5 essentially is a successor of MQTT 3.1.1. It has non-backward compatible. But the nice thing I wanted to point out is in HiveMQ, if you want to run the MQTT 3.1.1 and then MQTT 5 to the same broker, we have this capability in the HiveMQ broker too. So that's kind of a plus feature. You don't have to worry about, well, which version of MQTT protocol am I kind of working with the broker. Just send them anything. Our broker can handle it. So, okay, but that's MQTT 5 and specific. And then it was released in January of 2018 and official release in March of 2019. It's got many new features and essentially is a clarifications of the 3.1.1 specification. The goals of MQTT 5 as such is essentially there are enhancements for scalability and large-scale systems. So basically positioning itself ready for cloud native, for this cloud native world, working with Kubernetes, with clusters and everything too. It's scaled up and down. It's kind of really well designed for that. And basically there's also error reporting that's been improved in this release. And also some common patterns get formalized, including like capability, discovery, and request responses kind of pattern. And the extensibility mechanisms, including like user properties. So I would kind of go a bit into detail with that. And then there's also performance improvements and support for small clients too. So some key new features. So let's kind of take a look. Now, among many features, I just want to highlight just a few. Essentially, first of all, session and message expiry. This is essentially an optional part of the connect message. And basically, it will help with expiring the session interval in seconds too. So if the broker, the broker essentially will expires the session after the given interval as soon as the client disconnects. And then publication expiry interval is an optional part of a published message too, and then applies to online and queued messages. And okay, now then let's take a look at the user properties. So user properties essentially allows you to define, certain metadata headers too. And it can be part of most MQTT packets like connect, right? Pub and for publish and sub for subscribe. These are like UTF-8 encoded strings it supports, and also it supports an unlimited number of user properties can be added too. So this can be helpful too. It gives you more flexibility if you want to have any kind of user level kind of configuration things that you want to pass on. You can leverage on these user properties, and you can have unlimited number of user properties in there too. Now, also bear in mind too, all of these key new features, a lot of these are just optional too. You don't have to use them, but as such too, if you use them, you can basically, kind of be more ready for any kind of cloud native kind of deployment situation, such as the shared subscription. And also just a note to let you know is that HiveMQ already supported this shared subscriptions even before MQTT 5 became official too. So it's already been in MQTT or in HiveMQ. So as you can see too, like HiveMQ kind of influenced the decision and gets this incorporated into part of MQTT 5. But as such is a vendor neutral kind of features. So useful for scaling out backend subscribers and help with client load balancing and everything. So it helps with upscaling and downscaling of clients at runtime possible. And is perfect for cloud native scenarios too. It's again optional features. Not all vendors support these particular features too. And just a kind of picture is worth 1,000 words. So just a quick thing, right? So you can have the client publishing to your broker, and essentially too on the subscription side, you can have multiple clients subscribing, share the same subscription to the topic together too. And as you can see, you can have one topic here, another topic there. You can have multiple clients kind of share this same subscription too. So essentially that's what it is. So. And now there's also another feature in MQTT 5 that's worth mentioning is the MQTT request response pattern. Now, just want to point out is that it's not the same as our typical HTTP synchronous client-server based protocols too, such as HTTP. So requests as well as responses they are at least like topics and can have more than one or no subscriber in MQTT too. And as such too, this particular pattern, right? So it basically means that the client must subscribe subscribe to a response topic prior to sending the data as well. So it's a bit more on like a business level kind of acknowledgement kind of needs to. And it's essentially to helps with like the correlation data header for correlation of the request and its response. So a bit more kind of servicing things on the business kind of in an abstract sense, right? Servicing the business request and response needs. As such in here too, if you take a look at the picture, right, you can publish that to the broker, and basically then application will then subscribe to this topic and get the messages. But basically too, you also return in this case too, you have to also like indicate the request and the response before you establish the connection too. So then they kind of correlate with each other about who is requesting and who is responding. So. Okay, so in this part too, I'd like to quickly summarize why is it like MQTT is the protocol of choice for IoT. As you can see, it's very lightweight, it's bandwidth efficient, right? And essentially, MQTT has a control packet structure of a fixed header, which is only 2 bytes, and then there's also a variable header and can have like up to 12 bytes, but that's not even kind of required. If you don't use it, you don't need to include this variable header in your packet too. So you can actually have a very extremely lightweight, like very little overhead type of protocol. So it's really useful too. So just wanted to kind of point that out. And it's data agnostic. It supports all kinds of data. You can have images and text in any encoding format, encrypted data, binary data, blob, and anything. So it's pretty kind of flexible. And then also this continuous session awareness. Now I quickly kind of go through retained messages, last will and testaments messages, right? And broker will store the messages when it's offline. So the broker is really essential in terms of helping with the persistence of data between different data kind of directional kind of like movement, because you got this broker is your friend, right? It helps you with retaining all of these messages or taking care of things for you. Should the network goes down, should something dies, it takes care of things for you. So and okay, so now then I only have a few minutes left, so let's kind of quickly take a look, right? Use cases for MQTT. So IoT, right? That's kind of essentially, that's what it is. The strength is for IoT, Internet of Things, or industrial IoT, kind of on that level, because of how efficient, as you can see with this pops up kind of broker kind of model that it supports. And then of course too, there's also Industry 4.0, right? Industry 4.0 essentially, it's kind of a nutshell, is essentially an interoperability among many disciplines, different types of systems that comes to work together to create a solution for like industrial size kind of application systems kind of level of kind of scenario. So, and then as you can see too, use cases like industry verticals like automotive, logistics, manufacturing, energy, you name it. And then consumer side, there's smart homes and lifestyle. All of these can be use cases for MQTT. There's also a question too about MQTT. I mean, essentially too, it's not restricted to only IoT type of application. You can actually use it if you need some kind of messages kind of mechanism to handle data like really quickly and very lightweight, and also can operate in constrained environment. MQTT can also be your friend, right? So now, integration with other frameworks. It's basically, MQTT is so flexible, you can actually integrate or kind of interoperable with streaming platforms such as Apache Kafka. Like in HiveMQ, we have extension SDK that we can work with Apache Kafka. And then you can also kind of integrate with other brokers too. Say, for example, HiveMQ can work with Mosquito. You can, because of their structure, you essentially, it's like building pipelines of data that can travel through different pipelines, in your whole kind of like stream of data travel, through time and space too. Think of it like that. And then runtimes, you can, for example, HiveMQ also have plugins that would support a Spring Boot type of situation if you're a Java developer. Now, achieving IoT scale, we want to kind of illustrate that this is what we want to try to achieve, IoT scale. We're talking about in the billions of publishers per minute, like 2.7 billion of publishers, right? And 100,000 topic subscriptions, and an X number, billion, X 100 billion connected devices, and 100,000, or actually 100 billion queued publishers too for one queue, for example. So these are the things that this MQTT can support, how fast this can be, right? So in summary, MQTT is a preferred protocol for handling IoT messaging. It's asynchronous, it's loosely coupled, it's simplicity, very lightweight, and it helps in operate in a constrained environment, in environment that has high latency network that's unreliable, can drop anytime, limited battery and other resources. So as you can see, it's really ideal for that. So so I think I don't think I kind of talk about comparing with some of the other protocols, but next time follow me too. So I wanted to first of all though to kind of like point you to trying out the HiveMQ Cloud on this link, right? So let me really bring this up. So if you go to the HiveMQ website, there's a sign up now. Then I want to ask you to also join my Twitch stream every Wednesday at 2 p.m. US Central Time. And this is how you can get a hold of me, on my Twitch stream. I will be doing more demos and things like that. So, and these are the different resources. We'll be sharing these slides with you. And any questions, please let me know. And this is how you can get a hold of me. So I wanted to, again, thank you all for having sat through this session. I hope it has been helpful for you, and I'll be here to answer your questions either now or later, and connect with me on my Discord. Thank you.